Okay, I've got another update already. It's W5HRO. I've already discovered exactly where my final problem is, and I hope it's the final problem. I didn't do any. I would have had this already. I would have known this already before I uploaded the last video, right? But the problem was I was out of fuses. So I didn't have a fuse in here, and I had pulled it out anyway, and I'd put it in here, but I kept popping this one, and I got down to my last fuse, and I had my last fuse in there, so I kept testing it without the modulator side plate supply on, which is what I wanted to do anyway. But I couldn't do any more evaluation until I went down and got some more fuses, and these things are not cheap. These things are like $6, $7 a pack, and there's two in each pack. I got 2 packs of 10 amps and 2 packs of 15s. So I only need the 10 amp in the modulator side, and I might be able to get away with the one on the RF side after what I've determined. So I put that in there, and the first thing I did was I had the negative limiter unplugged, and I had the input to it just grounded so it wouldn't hurt anything. So when I modulated, it just go down through the limiter and go down to the negative peak would go down through everything down to chassis ground level, chassis ground reference level. But I didn't really have the audio turned up that high when I ran the test. But I started out with this, and I keyed up, and I kept hitting this button, bang, 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 to make everything key as fast as I could. And that humming, that charging sound, that where it was going, and it was like the sound kept getting shorter but louder. That's gone. So then the next step was, I think I told you, I thought, well, I think the problem is it's because I have two separate plate supplies, and in most people's applications, they have a single supply for both the modulator and the RF side, right? So I probably needed to hook up that to the primary winding too, that keep alive supply, because it's always on now. And of course, I've got that 200 volt, negative 200 volt supply on the control grid while it's on, while it's just sitting here idling, so it doesn't hurt the tube and it won't draw any current. The tube stays in cutoff until I go to transmit and grid drive gets applied. So after running this last test, I did it late yesterday evening, well, it wasn't late evening, it was probably like 5, 6 o'clock, something like that, 7 o'clock. And I just took a little box and I took some tape and I kind of like folded it over so I could stick that. I did find that other diode that I had, and I just kind of stuck it there to kind of hold it, and I used 2 clip leads. And that end of the supply going to the limiter, it's like 500, and I think it's like 30 some volts. It's over 500 volts, so it's pretty hot. And sure enough, I started keying down with it that way, and problem's gone. The problem has been eliminated. That charging sound and the blowing of the fuses, it's gone. And I even turned up, you saw where I left it. That's where I left it. I just started testing just to see what it would do, and everything is normal now. As a matter of fact, it's not modulating up as high as it was. There was something going on. I think what happened is when that blocking cap shorted, it damaged this meter, maybe the PEP circuits on the meter, because when I go to average power, it reads fine. So, the RMS average scale, which is actually average power is what it is. So it all works normal. So that's, I think, my peak reading thing. But after I did that, after I fixed this thing and I hooked this up last night, I started checking and it wasn't slamming anymore. And when I modulate, it was going up to almost 2,000, which is, I think, a more realistic power output, modulated power output on this transmitter, because I don't have these 810s. This modulator is not beefed up all the way yet. I've only got 2 6A3s trying to drive the things, and it's dying. They're dying. They can't drive the 810s very well. So I've probably got maybe half power, maybe a little more coming out of this modulator. Wait till I get it up all the way. That's the next step. That's the next thing on the agenda, is to get the modulator in this speech amp driver rack all redone for the voltage regulation on the 810 grids and everything, and that's going to be one of the next things I do. So I'm not sure if I'm going to do it now, but I may have to go ahead and do it, because I am going to have to do one thing. Because when I ran this test last night, the one thing it does is it You know, I have the plate current meter on the 810s, right? Well, this is the Class B bias. There's minus 155 volts just sitting on the 810 grids all the time. When I turn the power switch on and everything warms up, I've got minus 55 volts on the grids of the 810s, which is what you're supposed to have it at. But that's Class B, it's not in cutoff. So I'm getting like 530 some volts on the primary of that modulation transformer. So I was seeing a solid 100 mil static the whole time. But part of the problem is too, is that I have swamping resistors on the grids to ground on the grids on the 810s because of the problem with the 810s. And we'll go out in the garage here in just a minute, and we'll go over that. I've got some circuits kind of roughly drawn up, and that's kind of what I'm going to show you now. So let me stop this, and we'll go out in the garage with the RF deck, and you'll hear me go blink, and it will you'll like I'm going to be gone, but it's going to be a blink of an eye here. Blink. Didn't even know we were gone, did you? Now, here we are several hours later. It's nighttime. I'm out here in the garage shop here with the RF deck on the bench. And let me recap what I determined what was wrong with this transmitter the whole time. If you remember, I found out the end of last winter my old tube in here was actually bad. And when I put this tube in, it was like a miracle. It's like, you know, something happened, like some genie snapped his fingers and gave me a wish or something. The whole thing magically started working, right? Well, I got on that first night, made a couple long transmissions. The next night I got on there, I made a couple transmissions. During the second one towards the end, it's when I started the second QSO, all of a sudden I keyed up and the flash happened. Well, it's because when the power finally came up, this old plate blocking cap that was in there, this was the main culprit. It was starting to leak and it was shorting DC across. And that's what was going on the whole time, and I didn't know it. And I'd get that major flash like, what the heck? Well, the first thing I had to do, of course, was, you know, on my power supplies, I've got a separate plate supply. And every time that would happen, it was the modulation on the 810s was still coming across to a dead secondary because whenever it would happen, it would blow the fuse on the plate supply for this guy. And so this had nothing on it. It had no plate, no screen, nothing, no voltages. So, and it kept going across, and every time it would happen, it would just wipe out this original 1625 I had in here, and it shorted it out. It killed the tube. And that's what was going on. So I had to, you know, like in my first part of this video earlier today, you know, I had to add that relay to add a failsafe. That way, whenever the AC voltage on that supply dies, when that fuse blows, it automatically lifts up on the modulator side. Or anytime you lose the, you know, power to the this RF deck side primary on that high V plate transformer, anytime you lose primary voltage, the other side lifts off instantly. So that's how I've got it. I've got a fail safe. I created an AND gate in there because the one has to be there. If not, the other one's not going to be there. If the one lets off, the other one's going to let off. And that's how that was a critical thing, because I wouldn't have been able to debug it, because it would have just kept doing damage, and I had to stop it. So that was the first main thing. I had to, like I said, I had to troubleshoot. I had the backwards troubleshoot, right? I had to solve the worst problem first. So I did that. And then the problem is when I finally realized this was the main problem after watching that video the other night, after watching that, yep, did it again. Yep, did it again. Yep, did it again. Because it was arcing across the cap. And so as soon as I found that out and I put this guy in here, the problem was, it was started working. The problem is that the main difference was when the Keep Alive supply for the 3 diode negative audio limiter, I was switching it on and off, and it wasn't on. It was like off until it was on. it would only engage, it would only connect to this, it would only connect to the limiter, which goes through up through that diode and down through the secondary. It would only be there when I transmit, right? It would just come on when I'd key the transmitter. And that's how I had it. And then it would actually short the secondary down the ground. Well, when I finally found this, I'd already modified, remember I've already modified the thing with this negative 200 volt supply that I have in here. So when I'm at idle, I've got negative 197 volts on the control grid on the 4400, so it keeps the tube in cutoff, so I can leave that keep alive supply on all the time. And so it's going to be on the secondary. For whatever reason, you know, like I said, I know now that I was right. It's because I have two separate plate supplies, right? One on the modulator side and one on the on the RF side, one on the modulator side. So what was happening is that for whatever reason, just when I key it repeatedly, really close together. I mean, I could go like click, 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 and it would still do it. But if I did it really fast, I could make it happen like within like 2 or 3 clicks. And it's like something was building up. And I think what might have been happening was, you know, as the plate voltage was going through to the secondary with that keep alive supply on there, and then letting off again at the same time the modulator side was letting off. Maybe when the 810s were sucking the current away from the winding on the primary side, that maybe it was just spiking back and forth. There were some little surges here and there between keying and in between, you know, on and off, on and off, on and off. That the energy was actually, it was in fact going across to it was like going the reverse. It was going from the secondary or the primary, and maybe it was building up on the primary, or maybe it was building up on the secondary. I don't know. But I think that's what was causing my frequency counter, and that I don't think my MFJ meter, I don't think the PEP scale on it's bad. I think it was just whatever was happening, the energy was building up somewhere. And on my modulation transformer, I have it's on big insulated standoffs. The frame's isolated from ground. So if something like that was happening, so where was that energy going? I think it was being discharged to the ground system. And that's why it was messing up my meter, and it was just discharging, or it was getting through somehow to the center conductor of the coax. Maybe, I don't know. Something was slowly like discharging like every once in a while. Because I tell you right now, I've never seen I thought I was just overdriving my frequency counter, but the way that my sampler is, it's a little, it's just a toroid with wire around the toroid that's not even touching the center lead going through it, because it's insulated with the dielectric of the coax, and it just goes down to like a 300 watt 50 ohm resistor to ground is what it does. So I got a 50 ohm input for the scope or counter or whatever, and that's what it does. But it was spazzing out everything, and I think it was just somehow getting into all my equipment on top of the transmitter. So let me show you what I have here. This is what I did to figure. What I'm getting at is, as soon as I unplugged the keep alive supply today and tried it, it was last night when I did it. It actually went away. If I would have had more fuses, I would have added this part to the video that I uploaded yesterday. So, you know, when I took it back in there and started playing with it, what was I going to say? Is that the first thing, what I mean is when I was in there, I'm getting all turned around here. When I was in there last night, when I was, you know, trying this out, I unplugged the keep alive supply. Well, I did that earlier in the afternoon after I'd already uploaded the video. I did it a little bit like an hour later or something like that. And, I noticed when I would key real fast, that sound, that build-up sound I was hearing went away. I went, okay. So the next step was last night after it got dark, I had some time after dinner, I did this, right? I didn't use this resistor. I just had this connected to, see, my keep alive supplies, it's running around 530 volts, I think. It's pretty hot. But by the time it gets up through here and gets here through the secondary, it's just under 400 volts. And when I key the transmitter, it's like around 300 some volts. It's like 300 and maybe 30, 350, something like that. I probably need to decrease the voltage a little more I probably should put a voltage divider maybe to knock it down just a little bit somewhere. It may be a little bit too hot. I probably should have it barely 300. It should be sitting right at 3 at the most, I think. But anyway, so when I did this late last night without this resistor, I did this. See, I went right to the primary. I keyed it multiple times. Nothing. It was like that problem was gone. And I even turned up the mic gain. Did I say this earlier today in the first part of this video? I turned up the mic gain, and I keyed the mic. And no, I didn't key the mic because I went ahead and I had to short that across that switch again on the audio lead because that switch is intermittent and I couldn't get the audio to go across it a lot of the time. So I went back and I shorted that. So every time I hit that red button on the front of the transmitter on the exciter below this deck, it would, it's keying everything and the audio's going across. So I went, and I just had the mic gain turned up about a little less than halfway and I just repeatedly did it real fast like that. And nothing was happening. Like I said, there was no glitches. I think I did talk about that in the first part of this video. I realize now that that'll solve the problem. The thing is, like I said earlier, I didn't really cover this clearly in there when I mentioned it. The problem is because my 810s, I always had the 810s. The bias supply on the 810 grids, the control grids, are always on. They're always sitting at minus 55 volts. When I turn the power switch on the transmitter to warm everything up, that supply comes up, and there's minus 55 volts plus or minus a volt or two there, right, to get the right amount of 60 mils of resting current on the plate. But with this voltage here now, it's a little hot. It's like 500. If I get that down the same as on this side, what I'll do is I'll add these two resistors and just get one here that's as close as I can get it to drop it. It might drop it down somewhere close to where this one is. Maybe not. I can try it and see. But I bet it's going to be somewhere darn close. It'll be probably within maybe 10 volts. And that'd be close enough. So that's what I can do on that. But, what I was getting at what was I saying now? Is that because they're at minus 55 volts, when that voltage goes on here, like last night with that 500 some volts, I'm seeing like 100 mils of plate current or cathode current. I'm seeing 100 mils of cathode current on the 810s. And that's, so what I'm going to have to do is I'm going to have to add a relay down there on the modulator deck. So when I key up, there's going to be one more relay that switches. Then what I'm going to have to do is it'll have to switch to this minus 55 volts. And then it's going to be a lower negative voltage because I'm going to have to pull the 810s in the cutoff so the 810s aren't drawing current. So that's what I've got to do. So that's why, I hate to say it, but I won't have this transmitter back on the air this winter. It's going to be next winter. I may get it going this summer. But it's going to take me time to go through it. Because if I'm going to pull the modulator rack out, I want to go ahead and do that mod. Why do all this switching and stuff and hook everything up when I'm going to have to modify that old circuit that came out of CQ magazine? It's too bad I don't have that out there. I could have covered that right now, but I'll cover that. Maybe when I go to pull the modulator rack out, I'll do another video and I'll draw up the circuit and show you what I'm going to do on that. But I swapped the inputs here years ago with a couple 15Ks to try to stabilize things, but I didn't want to go any lower. What the guys did in the old days was they'd put like two 5Ks here, or like the 1.5Ks. They'd put really small resistors here. Then they drive it with about 45, 50 watts. They'd put a really high power driver because the 810s, because the issue with these. But the mod I'm going to do, it eliminates the issue with all of that. So that'll be great. So I'm just going to have a bias switch, and when I key the transmitter, it lets off whatever voltage this has to be, and it goes back to the minus 55 or whatever. So that's what I got to do. So I'm going to have to I'm going to have to incorporate that bias switch relay circuit in that old circuit from CQ magazine. But I am going to do that. It's going to work great, and that'll bring the power up on the modulator. Because I'm going to have fixed bias on the 810 grids, no driver transformer. I bet the fidelity comes up tremendously too. That's if I don't have to use it. Well, the thing is, I'm going to use an interstage transformer to uh, control from the what is it, uh, it's going to couple the, what is it, what's the interstage transformer going to go to? Oh, it's going to go from the 6SK7 compression compression AVC tube to it'll go to that transformer. Then it's going to go to the grids of the what are those six, not there, what I have in there now, 6A3s, but what are the tubes I'm going to use? 6AS7s or something like that. Is that what they are? They're just like 6A3s or they're like 6B4Gs, but they have separate cathodes, and they're also used for voltage regulation back in the day, but they're also low mu triodes. That's what I'm going to do. So it couples to the grids of that, so I can control the voltage going to those, so I can get the right grid voltage on the 810s, because those are going to be cathode followers, right to the 810 grids, which is going to be great regulated grids on the regulated 810 grids. I bet it sounds a lot better too, because it's going to eliminate a bunch of stuff. But I go to do that, and who knows? I may want it could throw. Like I said, you improve one thing, sometimes you cause a problem with something else. But I don't think that's going to be the issue with that. But I think I have the major problems with this pretty well resolved. And I'm holding it on there so you can see what I'm doing. I was going to go over all this, but I'm not. First of all, too, is that this is just kind of, this is a rough sketch, because these 810s have direct heated cathodes. They don't have cathodes that are grounded like this, and you go through the filament winding, then ground, then center tap. It's the same way with this guy. I just drew this here to simplify. I basically simplified everything. So, but like I said, my problem was it was doing something weird. I was getting some kind of a weird energy buildup that I think it was discharging either on the ground system, or it was or coming across on the hot lead of the audio. That was in addition to having the old DC plate blocking cap leaking, shorting DC across everything. That was the number one thing. So that, and the other thing only happened because I made the modification to the, like I said, the keep-alive supply to where it always stays on, and I just hold it in Class C cutoff until it's, until I go to transmit. And I'm going to have to do the same thing to the 810 grid bias. So anybody, like I said, this is great. I mean, this modified negative limiter I've done, and the way I've got this, is way better than all the other limiters that people have been using, because it requires 2 more resistors, but trust me, it solves the issues. It really stabilizes everything. And it also, all the damage that I've had and all the arcing, all that sparking, if I didn't have this extra resistor, I bet you one of these diode blocks would have gotten shorted across or something. Doing what I've done also protects the diodes tremendously. But the problem is with this diode, and if you don't make these two double and to both equal and parallel what the other one was, and then you're going to have a problem with this diode here, because when it comes up, you'll see a square wave in the current. The problem was when somebody came up with that original tube limiter circuit back in the late 40s, whenever it came, because I know guys were using it back in the late 40s. They were using it with like a big industrial diode tube on the big stuff, but they were using it in the 50s a lot. That mod was still being used throughout the 70s. The same mod, but even with all the old tube stuff that was still on the air. But people did, nobody had SPICE simulators back in the day to analyze what every single, people didn't, well, what's the current doing through that diode? People weren't looking at that when they designed that circuit. They could have cared less what the current was through that tube they had in there, right? They didn't care. And they didn't have the equipment. They could have analyzed everything. They would have had to put series current meters and everything, and then measure the voltage. They could have done measure the current of this one, then measure its voltage, then measure the current. It would have been hard. Then they would have had to draw it. They would have had to plot it out by hand, and nobody was going to do that because nobody would have even thought that that could have been an issue. But since I put it on the SPICE simulator and I started analyzing the original circuit, I realized, oh crap, there's a problem. So, but not only does it correct that problem, is it protects these diodes, and the diodes in my limiter have held up, which is fantastic. So it did that. If anything alone, having the extra resistor is worth doing it that way. Then this is just soft limiting, I'm just trying to eliminate the sharp edges. A 1K, it doesn't look very pretty, but the sharp edges are already rounded and it's gone. So that's all I care about. It's good enough. Otherwise, I'd need about another extra 100 volts to be able to do that. Well, maybe not. If I wind up being able to get away to reducing it a little bit, I could probably get away with increasing this resistor a little bit. And I could eventually do that. I might do that because that's that one I've got mounted right there behind the, it's there on the side of the chassis. I mean, side of the cabinet there by the just right below the RF deck, kind of like level with the bottom part of it. Remember, you've seen it. I mean, I've done many videos on it. So anyway, but I've had people ask me, well, how am I with a grid leak resistor? How am I, clamping the screen right of the tube, the 4400? Where is it? There. I got to figure out where I'm going here. Well, I'm using the regulators, but I could get away. I wouldn't need the 1625 if I would just increase this 28K. I'd make it a larger value, then I could limit the current that way, and you wouldn't even need it. But my original intent was to make this guy work automatically with this guy's control grid, and I can still go back and do that if I wanted after I get it working this other way first. There's a way I can still do it. I just have never had the time to really go through because I've been dealing with all this other stuff ever since I moved this transmitter out here to California from Oklahoma. So it's taken a lot of time. So, but my plan was to make it work together. But it's going to be nice now having a manual, to be able to manually adjust this thing, because I'm just going to manually adjust this voltage with that circuit. And by the way, here's that circuit again. I'll hold this up there for a bit. But that's kind of the plan, is I'm just going to use that. And then what I can do is I can bleed enough current away from those regulator tubes to get them to dim down just a little bit more. You want to dim them down all the way until they, just until the point where they don't extinguish, because you don't want them to have to reignite every time. You want to get them just down to the point, and they go down, but they don't. What I do is, on the screen of my tube, the way I run it, the way I have it regulated, that regulator string, I'm getting 550 volts. Regulation, that's where the regulation point is. So what I do is, and that's more than 30 milliamps. So what I do is when I adjust the loading knob back here, right, my loading knob here on the RF deck, I drop the screen current down to 30. And when I do that, it drops the screen voltage down to right at 500 volts where it's supposed to be. And that's how I do it. Because if I left that, if I had 500 volts of regulation and not 550, and because I want the screen at 500. That's where it's supposed to be. That's where it needs to be when there's no modulation. And if I had, if I did it differently, then I'd have a problem, right? I'd have what was I saying? It would be regulated at 500 volts, and it would be too stiff, and it would take a lot more to get it to go down. So that's kind of why, but doing it the way I've done it, taking it up to 550 and then bringing it down just below the regulation works a lot better. And now I'm going to have this where I can bleed the extra current off, then I can limit the current that way, and I can make those regulators dim all the way down as far as I want them to, which will also improve the positive modulation even more. One last thing here, I put this 1625 is bad, but I put it in here because I found some aluminum brackets on Amazon. There's a box of 10 for like $6 or something. So this cap's going to go anyway. It's not going to be used anymore. I'm probably going to cut part of this L off here. I'll probably cut it right there between the two holes and round the corners off and cut a little bit off the top. But essentially, this 15K resistor, I'm going to have ceramic, short little ceramic standoffs. It's going to be mounted probably like right here. I can cut maybe this part off and make it a little shorter and then file the edges down around it. Because the connection from here, this is where the screen voltage is feeding from, is this point here, and it's going to go to the base of the resistor, right? And at the top of the resistor, I'm going to have the 0.01 cap to ground, and then I'm also going to have the wire that connects to it that I'm going to run back down through the chassis through a grommet to the screen, because I have to have the plate shorted to the screen. I said the other day, I was thinking it was going to be the plate. No, it's for the screen, because I have to be able to short this to the screen pin. Before I was able to just do it from right here because I had the screen shorted on the bottom side, but now I have to do it differently to do this modification. So that's just going to sit right there nice and pretty, and I'll just, it's just going to stand up a little bit above the tube. Then I'll have the wire that goes to the plate cap on top of the tube right from, where it's at this point, right here at the top. So it's going to work great that way, I hope. I hope. One thing I'm also going to do is I don't like the relay that I have in here. The thing, it's too slow, and I've got another one of these NTEs, and this is the right number of poles. The other one, the contacts, they're really skinny and small, because it's a 3-pole. It's a triple pole triple. It's a 3-pole, it's a 3-pole double throw is what it is, right? And this is the double pole double throw with bigger, thicker, whatever you want to call those things, the wipers and heavier contacts. So I want to use this better relay, but I got to change the socket because this has less pins. So, and I'm going to rewire that anyway, because I didn't like the way I put that diode in there, and I'm going to do some more bypassing and everything on it. I want to guarantee the RF doesn't get in there. So I'm going to do that. Then when I get all that done, I'm probably going to take it in there and just check it with the modulator side plate supply fuse removed, and just make sure everything's still switching properly when I hit that button. Then when I get that done, I'm going to probably pull out the modulator rack, and there's a couple ways I could do it. I mean, I could make a voltage divider here and drop this voltage down to the point to where maybe I could drop the plate current on these things down at idle, because they're sitting in Class B instead of Class C cutoff, But then I may not have enough voltage to solve the problem it was having. So I'm probably just going to do it the way I was going to do it. I'm probably just going to go ahead and what I'm probably going to do is I am probably going to have to order one more of these relays here, because I'm going to need one on I could go with a single pole double throw relay. I might be able, because what I was thinking about doing was I'd have to drill another hole on that modulator rack to stick a relay on top to plug it in like this, which is what I prefer. I prefer these old octal socket relays over the other ones. So anyway, that's all I'm going to cover for now. And just remember, if you're doing these negative limiters and you're going to leave them on, you've got to do a bias switch here on the control grid of the RF tuber tubes, and also on the grids of the modulator tubes. So you got to do it in both, otherwise you got to switch that supply on and off from transmit to receive. So that's all for now. So I hope that's entertaining and educational. I hope I covered everything, and I hope those schematics help some people that have been having some questions. 73s for now, and I'll get around to upload another video here maybe the next few weeks or so, maybe even before, who knows. 73s.